Hello and welcome to another RDO Hangout. Today, Lars Kellogg-Stedman will be talking about OpenStack Heat and deploying things with it. Thank you so much for joining us. If you have any other questions about RDO, we're online at openstack.redhat.com. Turning it over to Lars.
All right. Hello, everybody. My name is Lars, and I'm going to talk about using Heat to deploy things in OpenStack today. Let's see, there we go. We're going to do a brief overview of Heat. I'm not going to go into detail about installation and configuration today. We're going to look at the Heat template syntax, and then we're going to look at a series of increasingly complex templates until we reach a reasonable end state. And hopefully folks will have a lot of questions at that point. We'll have time to go over those at the end. If you are just joining now, Rick was mentioning there is a RDO Hangout channel on Freenode that we are gathering in for people who have questions and stuff as we go forward here. The examples that we're going to run through and towards the end of this Hangout look really similar to the official examples, which are linked to here. And hopefully you've noticed the description of this video has a link to these slides if you want to look at these on your own screen or after the fact. So these look a lot like the official examples. They get to kind of the same end state, but they were designed from scratch to make sure that I knew what I was talking about today. Everything you see here has been tested on my laptop, which is running Fedora 20 and the RDO Icehouse packages. If you want to run through these examples on your own, you're going to need to have something reasonably similar to that, and you'll need a functioning Heat and Ceilometer installation along with all the other OpenStack parts. So let's get started. What is Heat? Heat is the OpenStack orchestration engine. That means that it is something that can automate the arrangement, coordination, and management of complex computer systems, in this case, OpenStack resources, through the use of a set of modular templates. It ingests templates and egests OpenStack resources, and that was really just an excuse to put a heat grinder in the presentation. Just a quick overview of what you get when you install Heat. You end up with several services running. One of them is the Heat API itself. This is what you interact with, or what Horizon interacts with if you happen to be using the web interface. There's the Heat engine, which is kind of the business end of Heat. This is the thing that talks to the other OpenStack services and creates and destroys resources on your behalf and so forth. The Heat CloudFormation API, that's the Heat API CFN service there, is used when other parts of your OpenStack environment need to make callbacks into Heat to notify it of changes. And we'll see some examples of that as we go through things later on here. So I said I wasn't going to go into details about configuration. I did want to highlight one thing, which is that with the Icehouse release of Heat, there were some changes in how Heat handles authentication, in particular for things like those CloudFormation callbacks I was talking about. There's a link here to a really good blog post by Steve Hardy that talks about that in detail. I encourage you to read that before you try to proceed through these examples, or really, interact with Heat in general. Great. So we are going to move on and talk about Heat templates now. Heat uses Heat orchestration template format templates, or HOT templates. These are written in YAML syntax, and if you have not seen YAML before, we're going to go through that in just a few slides in just a moment. It's fully documented online. The documentation is pretty good. There's also support for the AWS CloudFormation template format, presumably if you are in an environment where you're transitioning from AWS services into OpenStack. But we're not going to look at that at all today. So YAML, very briefly. YAML is a reasonably human-readable markup language for presenting complex data structures in plain text format. So here's a list. The stuff on top here is kind of the long way of doing it, and down here at the bottom is a short way of doing it. But the important thing to remember is that both of these presentations are exactly the same, and they result internally in the same data structure. There's also syntax for mappings or dictionaries or associative arrays, depending on what language you're coming from. Also very simple, and again, the long format here is identical to the bottom format here. There are a couple of ways of putting blocks of text into your YAML templates. Here is the greater than symbol, which introduces a chunk of text where we do new line folding. So adjacent lines are joined by a single white space, and blank lines turn into a single new line. So what we see here becomes this if it were presented somewhere. And the vertical bar introduces verbatim blocks of text, which is often used, as in this example, for embedding things like shell scripts or other forms of data into your heat templates. So awesome, you now know everything there is to know about YAML syntax. So we're going to go on and start looking at heat templates in some detail. So one thing that they add to just the basic YAML syntax is this concept of an intrinsic function, which really just means a function built into heat. So for example, there is a function called getParam, which returns a parameter, which is an input to your template, and we will see this. You'll notice that that function call looks a lot like a YAML dictionary, and that's because it is. And what that means is that spelling is really important. If you misspell an intrinsic function, heat doesn't have any way to tell you, hey, that's an unknown function. All it knows is that you just tried to stick a dictionary somewhere in the middle of your template, and maybe that works, or maybe it doesn't. But you'll get a variety of errors depending on where exactly you've done something like that. Just checking back here on IRC, making sure people can see the video, looking for confirmation there. Anyway, moving on. Templates. Heat templates have 3 sections. There's an example template here that shows the parameters, resource, and output section. There's also a required version header that you need to template. You see that here at the top. We're going to look through each of these 3 sections. We're going to start with the resources section because this is the only part of a heat template that is actually required. So the resources section defines the resources that you want heat to create. Resource definitions look kind of like this right here. There is a resource ID, a resource type, and then 0 or more properties that configure that resource. Here's an actual example. This would make heat instantiate a Nova server for us using a Fedora image, using the m1.small flavor, using an SSH key that I provisioned to Nova, and using one of the neutron networks that I have available locally. Resources can depend on other resources. There can be explicit dependencies using the depends on directive here, but there are also implicit dependencies, and this is what you'll see most often, where one resource is referring to something created in another resource, and that creates dependency between the two, so that the first resource needs to be created before heat will create the dependent resource. And so here, this is getting information from a network that was presumably created elsewhere in the template, so that would have to be created before heat would create this server here. So there's lots of good documentation on heat resources. Online, there is a great list of available resource types. Just going to look at that briefly here. This is generated automatically from the heat sources. It is an excellent reference, but it is a reference for typically what is in the heat master branch, and may differ slightly if you are using a stable release of heat. So for example, all the work I've done for this presentation was done using the Icehouse release. So there are a couple things here in the documentation that don't match up. But for the most part, it's a great resource. It's not the only resource, though. Heat is a fairly introspective piece of software. It provides a lot of kind of self-documenting features. You can ask Heat for a list of available resource types with the resource type list command. This will tell you what resources are supported by your local installation of Heat, which may be different from what is supported elsewhere, because there may be plugins installed, there may be vendor-provided resources available. You can also ask Heat for documentation about some of those resources using the resource template command. That shows you information about the attributes available and the properties required in the resource. So going back to that example we looked at earlier, that Nova server we were creating. It works. You could actually, on my system, deploy a Nova server using this resource definition. But it won't work really well for you. There's a lot of local information hard-coded into that, like my SSH key name or the network user ID. So we'd like to be able to create templates that are portable and reusable, so they don't depend on your particular environment. You can do that with heap parameters. Parameters are inputs to your template that you provide when you create a stack. So here we have a parameter defined called image, which is a string. It has a default value. There it is. And it has a description associated with it. And, we'll talk about this in a second. We can refer to parameters like that with the getParam function. So here, instead of a hard-coded image name, we have included the image parameter. So whatever that is defined at the time the stack is created gets substituted here. Parameters can have a type associated with them, a description. They can have constraints, so you can validate parameters passed in by the user. And they can have some hints for UI display. There are details in the hot specification. When you are creating a stack, there are a couple ways of providing parameters. If you're doing it on the command line, which is what we'll see pretty much throughout today's Hangout, there is a -p flag here, which lets you put the parameters inline on your command. Now, as you can imagine, if you have more than a single parameter to your template, this probably is going to become unwieldy. So you can put your parameters in what is called an environment file and specify that with the -e command line option. An environment file is another YAML file that has a parameter section that maps values to parameter names. So here we are specifying a value for the image parameter. If you're deploying with Horizon, and I think this is the only screenshot of Horizon I have in this Hangout, you'll see the parameters listed here as potential inputs. And those descriptions we saw earlier, if you highlight one of the fields here, you would see a little pop-up help text with that description. So that's where they show up. And again, it is possible to do parameter grouping here in the UI and things like that, but I'm not going to look at that in any detail today. At times you want to know things about your stack because you're creating a bunch of resources dynamically, so you don't necessarily know in advance things like IP addresses assigned to servers. You need a way to extract that from your stack. The outputs section of the templates lets you specify exactly that, a list of things that you want to know about the deployed stack. Here we have an example where we are looking up the fixed IP associated with a Nova server, and we're making that available as an output called server IP. On the command line, the output list and output show commands let you interact with these. So, for example, here we are asking for a list of available outputs in the stack that we've deployed, and we see one here, and we can ask for the value of that output. There we go. These are useful, obviously, for shell scripting, just for interacting with your stack. You can also get at these through the Horizon web interface, and you can get at them through the Heat API if you're writing your own code to interact with things. Now that you know everything there is to know about Heat templates, we're going to start walking through some examples. We're going to start with one that is pretty simple, and they're going to stop being simple pretty much immediately after this one. So in this example, we're going to be using the, let me just close a couple tabs here. We're going to be using the simple.yaml template. Let's quickly switch over here. You can see that. There it is. It fits entirely on one screen. It has a few parameters, one resource, and an output. And all of these should look pretty much like what we've been looking at in the previous slides. We can create the stack like this. We're running heap stack create, pointing it at that template file, and providing a list of parameters on the command line here, and giving the stack a name. And now heap will tell us, hey, I am creating that stack. Well, wait a bit. This is a small stack, so it'll happen very quickly. We can run heap stack list to see what the status of things is. This shows us that the stack is complete. That's awesome. Once we have a stack up, we can start asking heap for information about it. We can say, show me information about the resources that my stack is deployed. So here is the OS Nova server resource that we deployed, and we can see that it was successfully created, which we knew because the stack was successful. We can ask for the output associated with the stack. And we can do things like Nova list and verify that we did actually create a server. So here is the server that we created, some active, has an IP address assigned to it, and so forth. Things can go wrong. If you see create failed, that usually means you've got a problem with your template. It could mean you have a problem with your OpenStack configuration, but more often it is probably a problem with your template. The stack show command gives you details about your stack, and that includes failure reasons in the stack status reason key. These error messages are usually pretty helpful, which is almost unique in the OpenStack world in some ways. They often point at the problem. If you are the local administrator and you have access to the heat engine log, that's going to be the best place to go for information, because in addition to the error message displayed in stack show, you'll see any backtraces and additional information coming from heat there. So let's look at a more complicated example. We're going to look at the WP naive template. Let's bring that up quickly here. This is a longer one. We are deploying a number of resources here. We're deploying some random string resources that are going to be used for passwords in the configuration. We are creating a whole bunch of network resources so that we're not relying on existing Neutron networks other than an external network. So we're creating a fixed IP network and subnet and a router, and we're connecting them all up. We're creating the necessary security groups to path the traffic that we expect to use. And then we're creating a MySQL database server, and we are creating a WordPress application server. I think I've covered that all there. Yes. So stack create command, very similar to the last one. This one we are dumping everything into an environment file called local.yaml. And if you go to the GitHub repository, you can see exactly what my local one looks like. You'd obviously have to modify that for your environment. And we'll wait a bit for the stack to create. Now this stack would create relatively quickly. Others we look at later will take a little bit longer. I want to quickly highlight something here. This is a section right here. One of the things that we're passing to our server instances is a block of user data, a user data script. So we're booting the Fedora Cloud images, which include on them a tool called Cloud.init. Cloud.init runs when the system boots, and amongst the thing it does is it looks for this user data, and if it gets a shell script, it executes it. So this is a shell script that we are passing in to Nova that will be executed by our instance when it boots up. So in this case, this one is installing Apache and WordPress and performing some limited configuration. One of the things that we're doing here is taking advantage of some of the parameters and resources we've defined. We're substituting them into this script. So here we are using this string replace function, which takes a template, and you'll see our vertical bar here, so we're introducing a verbatim block of text. And then we're taking some things and passing them into this template. We're replacing them there. So for example, we have this DB name. We're getting that from one of the parameters passed into our stack. Same for a DB user here. For the DB host key, we are actually querying Heat to ask it what the IP address is that was assigned to the MySQL server back up here. And so you'll see something like this in all of the examples going forward. In fact, you'll see pretty much exactly this in all the examples going forward, because we're going to be using this MySQL database and WordPress application server as our kind of standard example here. So we wait for the stack to create. Now we can look at a resource list for this new stack and see that it's substantially more interesting than the last one, because we've created all of these resources and it tells us a little bit about them here. But there's a problem with this stack, even though it deployed successfully. If you had tried accessing the website immediately after the stack finished creating, you'd find that you couldn't connect to it. And even if you waited a bit and could connect to the application server, you might find that the application server was unable to connect to the database server. This is a race condition because, from Heat's perspective, a Nova server is complete as soon as it boots up. But realistically, it takes time to do things like do the Yum upgrade that we have there and install and configure the application software. So we need a way to synchronize our Heat deployment with things happening inside the Nova servers. And that brings us to example 3. Vandervati is thinking about. This one will be using the WP symbol template, which looks remarkably like the one we were just looking at. But it introduces a new resource here called a wait condition. And we're going to look at that in a little detail here. So a wait condition resource. Most resources transition their states automatically. So Heat creates a Nova server. Heat monitors that server. When Nova says, hey, I'm done booting that, Heat says, okay, I'm transitioning this resource into the create complete state. and anything dependent upon that will then move on and get created. The wait condition is unique because it only transitions after receiving an external signal. Wait condition definition looks like that. There are actually two parts. There's the condition itself, and then there's what's called a wait condition handle, which is basically that is the thing that generates a URL that is used for calling back into the Heat CloudFormation API. So this means that we can make our Heat template wait for an external event that we generate before moving on. So for example, we can ask our WordPress server here to depend on the MySQL wait condition. This means that Heat will not deploy this server for us until after this wait condition is satisfied. There are a couple of different ways to signal that. There's a tool called CFN Signal, which is included in the Fedora images. It's part of the Heat CFN Tools package. And here we're using that. We're substituting this wait handle parameter into it. This is a URL generated by the wait handle resource. It's basically a EC2 signed URL that tells Heat, hey, the resource is created. So here we use CFN Signal to send that signal. You can also do the same thing with curl if you are booting an image that does not have the CFN Signal tool available. So here is the necessary curl command that does pretty much exactly the same thing. So if we see this in action, we'll go ahead and create the stack here, and then run that resource list command again. And what we will see is that some of these resources, there we go, some of these resources are going to be held in a create in progress or init complete state until after the server has finished the post-install configuration. So then we signal Heat, and then it will start deploying these other resources. This is just a visualization of the dependency tree in this particular stack, showing that here's our WordPress server, which requires this wait condition, which requires this server, which requires all of these network resources, la la la, la, and so forth. So now we have a way of synchronizing our deployment so that we don't bring up a server until don't bring up the application server until the database server is ready for it. So that's great, but what if we need more than a single application server? What if we want an elastic environment where Heat will dynamically create additional servers for us based on CPU load? We're going to be looking at the WP scaling.yaml template here. So this is the same requirements as the previous example, and it produces a very similar stack, except rather than a single server, it will have a dynamic number of servers depending on the CPU load on the WordPress application servers. So we're going to see a nested stack in this example, and we'll talk about what that is. We're going to see an auto-scaling group. We're going to see Ceilometer alarms and auto-scaling policies that connect metrics recorded by Ceilometer with threshold alarms with actions in Heat. So the first new concept here is a nested stack. Heat can treat an existing template as a resource primitive in another stack. So this allows you to create building blocks that you can use in your other templates, create a library of things that you frequently use, kind of like Legos for your OpenStack resources. In this example, the nested stack is this template here. So this looks really, really similar to the WordPress definition in the previous example, except it's by itself. It doesn't have the MySQL database server in it, and it has a bunch of additional parameters which are actually generated in the parent template, and we'll be passing them in the stack. And in fact, if we quickly bounce up here to the scaling template, we can see here. There we go. We can see here that we have specified a resource type here that is the name of a template rather than a built-in resource type. So let's take a look at what all this looks like. You can see it here, what we're just looking at. We've specified that this resource is of type our template. Now, that file name or the URL, this can be a URL also, must end at .yaml. Otherwise, Heat will think you are talking about a local resource type named that, and it will just blow up and tell you, I don't know what you're talking about. An auto-scaling group is a resource that can create and destroy other resources on demand. So here's what the definition looks like. There's some dependencies here that are particular to our stack. These are not something that you need all the time with every auto-scaling group. The important parts here are the min size and max size, which tell you how small and how big this group can grow, and of course the resource that it will be controlling. And here is where we're referring to our nested stack. A scaling policy defines an action that heat can take on an auto-scaling group. So for example, here we have a scale-up policy which would tell heat to add one server to the scaling group identified here. The policy by itself doesn't do anything. It's just an endpoint. And much like the wait condition we saw earlier, it can be used to generate a URL that can be used in an external tool to notify heat. Speaking of external tools that notify heat, we're going to look at ceilometer alarms also. The ceilometer is the OpenStack metering agent. It collects metrics for all the different OpenStack services. It includes an alarming feature, and it's very alarming, that allows it to monitor metrics for certain thresholds and then post to a URL when a metric matches certain criteria. This is what an alarm definition looks like. In this case, we're monitoring the CPU util metric, and we are looking for something where the average value over a 60-second period is at least 50%. The alarm actions here is where we get the generated URL from that scaling policy and pass it into heat. One of the things that we are doing here is specifying some matching metadata. This instructs ceilometer to only look at metrics that match this particular query. In this case, we are looking for metadata called useMetadata.stack that happens to have stack ID in it. The important thing to note here is that that's not something that is getting added automatically by heat. That is something that we are adding explicitly when we are provisioning our resources. You can see that in the template. It looks like this. We are explicitly adding a metadata key to our Nova server that has that value so that we can match that in our ceilometer alarms. So let's look at this going on here. We are going to create a stack and wait for the stack to complete. Now, if you are doing this on your own, this is the time to go out and get a cup of coffee, or maybe take a walk around the neighborhood, because this will take 15 minutes or so, depending on your environment, or at least it does on mine. As the stacks get more complex, and as you're doing more in those post-install configuration scripts, they take longer to complete. So we can look at the resources created by the stack, and one of the interesting things here is that everything in that WordPress server nested stack is kind of hiding behind this resource here. So we no longer see all of those resources listed in the output of resource list. If you actually want to see those resources, see details about them, see their status, you can kind of dig down using the command line tools to find it. Here we are getting the physical ID of the WordPress group resource. And actually, I think let me go. Yeah, this should be resource show here. I think that's a typo. Anyway, so we get that resource ID. We can plug that resource ID of the nested stack into the resource list command. That gives us a list of resources. Here we see this resource, which is an automatically generated name, which is our nested stack. And we can repeat the process, resource show, specifying the physical ID of our auto-scaling group and the name of this resource. That gets us the physical ID of the nested stack, and we can pass that to resource list. And finally, at the bottom of that tree are the resources that we have defined in our nested template there. You probably won't have to do that very often, but it's good to know, especially if you are trying to look up maybe an output or something you have to find in a nested stack and have not exposed in your parent stack. Moving on. So once the stack has been created, we can look at all of the things that it's provisioned for us. We can look at the ceilometer alarms that have been created here using the ceilometer alarm list command. And we can get details on one of those with the ceilometer alarm show command. That gives you a lot of information about the alarm. In particular, we can look here and see what metric we're measuring over what period. We can see the query that ceilometer is using to match those metrics. And so you can see here that metadata match we're talking about, and it also restricts it to things owned by our project, or our tenant, is what you might have used to call projects. And we can ask to see samples being considered by that alarm. Here we are asking to see samples from the CPU util metric. we are passing in a query, that's -q, using the same query that Telemetry is using, that alarm, and we see a bunch of examples here. You can see not a lot of server load going on right now. So if we were to create a new server, if we were to log into one of our WordPress servers, we could generate some load. A great way to do that is writing dd from dev0 to dev null, starting a couple of those in the background, and you would eventually see Heat spin up a server for us. I'm going to postpone actually doing that live until we finish running through the next example, which I think is very interesting. Because there's a problem with this example. It works. We get auto-scaling groups. We get Heat to automatically create WordPress servers for us, and that is awesome, but we don't have any way to connect to them. We don't have an address that we could send out to clients and say, here's how you contact the application server. We need a load balancer, and that's kind of the last part of this puzzle to make this something that's actually functional. So that brings us to example 5, where we'll be looking at the WP scaling lb.yaml template. So very similar to the previous one, but this adds a Neutron load balancer into the mix. So a load balancer resource associates a Neutron load balancing pool with 0 or more member servers. And the resource definition looks like this. This one says that it is a load balancer for port 80, associated with a Neutron pool, which we'll see on the next slide. Here it is. So a pool is a resource that manages a group of member servers. A pool has an IP address associated with it, and then it has servers that you add to it through a different resource definition. It has a monitor associated with it also, a health monitor. We'll take a look at that, I think, on the next slide. The subnet ID tells it what fixed IP subnet it should be associated with, from where it's going to get its IP address. And we can select a load balancing method. Here we're using round robin. You can also use least connections, and you can also hash the source IP of the clients to select the target backend server. A health monitor is a resource that monitors the connectivity of pool members, and it can automatically remove things from a load balancing pool if they're no longer responding. So here we are monitoring, just doing simple TCP connectivity checks, and has to fail a few times before we declare it to be inactive. A pool member is how you associate a Nova server, for example, with the load balancing pool. So you'll often see this in the same place as your server definitions. You give it a pool ID, you give it an address. Here we are querying a server to get the address using the getAttr function, and you tell what port it's working with. So let's go ahead and create this stack and wait for the stack to complete. Now we can verify that Heat has created a load balancer for us, and that the load balancer is active. We can see that there are members assigned to the pool, and that this member is active. And we can verify that the application server is available at the public address assigned to the load balancer. So here I'm using Heat output show to get the URL from the stack, and passing that to curl, and we're getting a happy redirect into the installation page. And that is all for the slides. Now, in about the next 5 minutes, I want to just quickly do a demonstration here where we will actually have Heat launch a new server for us based on CPU load. So let me quickly switch to a different window here. Yep, there we go. All right. So here we have some stacks available. Let's get the URL of that. There we go. Just verify that that's available to us. Let's also look at our Nova servers here that we've got created. We're going to log into one of these. So here is a WordPress server. We know that because it's got part of the resource ID embedded in the name there. So we're going to log into this one. Now we're going to start some load here. Dev 0, dev null, start up a few of those, we will see. Here we go. We will see the load average on this system start to rise, and we're going to bring up a different window here. Just a second. Feel the heat engine log and the oscillometer logs. Bring this up here. That is. There we go. And let me just switch that here. Red window? Yes, there we go. So there we're tailing the logs. So while that's going on over here, I'd like to open the Hangout to questions. And when this eventually does something, I will yell at everybody and we'll look at that screen again. So I'm moving over here to the RDO Hangout channel to see if there are any questions out there. I know that folks watching this video are lagged by a couple of minutes, so you may be just catching up with us. So there's a question here in the channel. Are heat and neutron load balancing production ready yet? I don't know the official answer to that question. I can tell you that in large production environments right now, using Neutron with just the open source plugins, there are some scalability concerns there. But if you're using the vendor plugins, then I think you're in good shape. But so I guess the answer is I don't have a good answer for that. I think that people are using it in production. Oh, hey, over there, sorry. You can see that heat has just triggered, the oscillometer has triggered alarm. Heat has just spawned a whole new stack for us. And in fact, if I just cancel this log tailing for a moment and run a nova list command, you can see that now we have 2 WordPress servers. So we have verified that our stack operates correctly. Anyway. So let me move this back to the slides here and just leave this up on screen. Whoops, too far. Here we go. So yeah, so everything in the demonstration today is available online if you want to run through these on your own or just review the slides. And feel free to ask me questions at any point.
Well, thank you for attending this Hangout. And a reminder that we're always on the RDO channel on Freenode. And you can find out more information about OpenStack at openstack.org or join us at openstack.redhat.com. Thanks a lot.